Hello everyone. I, Nilima Warhade, working as an assistant professor in the Department of Electronics and Telecommunication Engineering from All India Sri Shivaji Memorial Society's Institute of Information Technology Pune. In previous video, we studied about the two parameters or two characteristics of digital ICs such as propagation delay and power dissipation. In this video, I will be focusing on the other characteristics of the digital ICs such as fan out and voltage and current parameters. Let's start with fan out. Fan out, number of similar gates which can be driven by a gate is nothing but a fan out. For example, as shown in the figure, NOT gate output drives similar type of a gate and more similar gates can be driven. That means it is advantageous to keep fan out much more as large number of gates can be driven by the same gate. Moving further, the next characteristics is voltage parameters. Generally, we said 0 as a low level and 1 as a high level. We can define the voltage parameters as input voltage parameters and output voltage parameters. As shown in the figure, generally 0 to VIL is low logic level and above that, that is from VIH to VIL is a high voltage level. With reference to this, we can define the input voltage levels and output voltage levels. Input parameters such as VIH and VIL and output voltage parameters such as VOH and VOL. Let's define them. VIH minimum is the high level input voltage. It is the minimum voltage level required at the input of a gate for that input to be treated as a logic 1. Any voltage below this level will not be accepted as logic 1 by the logic circuit. VOH minimum is the high level output voltage. It is the minimum voltage level required at the output of the gate for that output to be treated as logic 1. Any voltage below this level will not be accepted as a logic 1 output. VIL maximum is the low level input voltage. It is the maximum voltage level that can be treated as a logic 0 at the input of the gate. Any voltage above this will not be treated as a logic 0 input by the logic gate. VOL maximum is the low level output voltage. It is the maximum voltage level that can be treated as the logic 0 at the output of the gate. Any voltage above this level will not be treated as a logic 0 output. As shown in the following figure, when the input of a NAND gate is connected to the ground potential, the output generated is VOH, that is high level output voltage. It means when you apply 0, the output would be 1. Similarly, when VIH is provided to the NOT gate, it will generate the similar outputs. Moving further, the next parameters are the current parameters. There are again certain inputs and output current parameters. First one is IIH. It is nothing but high level input current, the current that flows into an input when a specified high level voltage is applied to that input. IIL is the low level input current, the current that flows into an input when a specified low level voltage is applied to that input. Similarly, IOH is the high level output current, the current that flows from an output in a logic 1 state under specified load conditions, and IOL is the low level output current, that is the current that flows from the output in a logic 0 state under specified load conditions. As shown in the following figure, when the input is applied to the logic 1 state of a NAND gate, it will generate the output as IOH, which is a high level output current. And similarly, when IIH, that is high level input current, is provided to the NOT gate, it will generate the similar output. That's all for today's video. We will see the next characteristics in the next video. Thank you everyone.